Hello, hello, Science 9. Welcome to your activity on series and parallel circuits. Today we are going to do another lab. I am going to run through the data with you and you are going to answer the questions. So today, part A of this lab is talking about series circuits and how does the addition of a bulb affect the series circuit, and how does the current with the addition of those bulbs also become affected. So just like we always do, we have to make a hypothesis. So you're going to write your hypothesis right here beside your circuit, and you are going to predict what's happening to the brightness of the bulbs as we successfully add new bulbs in. You're then going to predict what will happen to the current as we add the bulbs in. Okay, so you're going to make two predictions right here. So I'm going to give you time to do that. Pause the video, write your predictions, and then follow along. So what I'm going to do is I'm actually going to do this backwards just for time saving purposes. In class, I would ask you to go 1, then add 2 bulbs, then add 3. But just to make this a quicker and faster way of doing this, we're going to go 3 to 1 because you could delete things quicker. So we're going to start off with 3 bulbs in a circuit. So there's my 3 bulb circuit. I have my ammeter connected and my circuit is open. So I'm looking to record down the current and observe the brightness of the light bulbs. So there we go. So I have a current of 0.6 amps. And if you notice, these lines are quite short. They're not long, they're not super short, but they're shorter. And you're going to see what I mean by that. So what I'm going to write in my data here is observed brightness is it's bright, but it's not super bright. And I'm going to have 0.60 amps. I'm going to go here. I'm going to disconnect this light bulb here. I'm going to move it off to the side. And I'm going to connect my thing back together. I'm going to turn it on. And now you will see the difference of the line. So you can see this is with 2 bulbs and the current. So let's go in and plug in our data. So more bright, not a very good observation, but that's okay. We're keeping it simple today. And it's 0.90 amps. I'm going to do this one more time. I'm going to get rid of a bulb. I'm going to connect it up. Turn it on, and you can see we are at 1.80 amps with an observed brightness of very bright. You're going to want to write that into yours and what the current was. Now we've collected the data, we've kind of seen what this looks like. We now need to analyze what we're looking at. So the first question asks you, how does the brightness change as we added more light bulbs? So you're looking at this column. Make sure as you answer these questions to use your data as you are answering the question. How does the current change as more light bulbs are added? So you can look at that there. And what do you predict would happen if we unscrewed a light bulb in a series circuit? You should know this from the videos prior. If not, go look at your notes. So you're going to use your knowledge to explain that. Predict what would happen if you added more and more light bulbs. What would happen to the current? What would happen to the brightness? And then here, provide one real-life circuit that behaves this way and some advantages and disadvantages in question 5 and 6. You can go online and take a quick gander, see if you can find those because we have not included them in your notes, but they are important to understand. So now we're going to go into part B, which is the problem focusing on the same thing, brightness of the bulbs and the amount of current flowing, but this time in a parallel circuit. So what we're going to do is examine this diagram right here. Ignore that this says 1, 1, 2, 3. It should say 1, 2, 3, 4, but that's okay. We're going to examine this and we are going to make our predictions, our hypothesis right here. What's going to happen to the brightness of the bulbs as we add more, and what will happen to the current as we add more. I'm going to build this circuit and we are going to do our observed observations. Again, I'm going to do it a little different. I'm going to go backwards 4, 2, 1. So now we have a parallel circuit. So with 4 light bulbs, again, we're going to work our way backwards just because it's a little easier. So I'm going to turn on my circuit and you will see that I have a current of 7.20 amps, and look at the brightness of my light bulb. So I'm going to go into here. Observed brightness is very, very bright, and we are at 7.20 amps. Go back. I'm going to turn this off. I'm going to disconnect one of these light bulbs here. Make sure that I can close up my circuit so that it flows properly. So get rid of one of those. I'm going to turn it back on. And as you can see, very, very bright. or very bright, whatever you want to say. And we are at 5.40 amps. All right, we're going to do this again. Turn off my this way, get rid of it here. This. All right, let's turn it back on. Again, you can see hasn't changed, still very, very bright, but this time it is 3.60 amps. And last but not least, let's get rid of one last section here. These. And still the same amount of brightness. Very, very bright, I'll say. And 1.80 amps. There is the data for the second half of the lab. You will notice that the brightness never changed, but the current did. You will notice it changes by exactly the amount, 1.8 each time. Give it a try to see if it does, okay? So again, how is the brightness of the bulbs affected as you added more? We took away, but you can look at your data chart going from 1 to 4. How does current change as you add more light bulbs? Again, using your data, explain the relationship. What would you predict to happen if one of the light bulbs was unscrewed? Again, using prior knowledge to answer this question from yesterday's lessons. Predict what would happen if you added more and more light bulbs to the circuit. What would occur to current and brightness of the light bulb? That's why it's 2 marks. And then again, go online, try and find a real life example of how a circuit that is wired this way and what are some advantages and disadvantages. When you are done this, ladies and gentlemen, you may hand it in, and I hope you have a great day.